We're going to be comparing fractions that either have the same numerator or the same denominator. And up at the top of your homework, I've given you a clue as to where we don't have to work things out. If you have the same numerator, which is the top number, the smaller denominator is greater. That's because it's like saying you're getting one piece of something. Would you rather share that one piece with 3 people or with 4 people? Well, if it's your favorite thing, you're going to get a bigger piece if you're only sharing with 3 people. Same thing here. You're going to get a bigger piece if you're only sharing with 7 people. You'll get a bigger piece if you're only sharing with 98 people. You'll get a bigger piece if you get, if we're looking at number 9, if you're looking at getting 2 pieces of something, you would get more if you got 2 pieces and you're only sharing with 5 people. If you have the same denominator, then the larger numerator is greater, because that means that it's cut into the equal number of pieces, like a pie or something. And if you get 5 pieces of that pie, you're getting more than if you just got 4 pieces of the whole pie. Same thing here. If you had 53 pieces of the pie, you would have more than if you just had 51 pieces of the pie. Then the last 3 are easy because you have a fraction with a whole number. A fraction is part of a whole number, so the whole number is always going to be bigger than a fraction that's just by itself. Number 13 says, Claire and Ramona each have a banana the same size. Claire cuts hers into fourths. Ramona cuts hers into sixths. Now, of course, you could draw a square banana, and the banana is the same size, and you have Claire, who hers are fourths, and then you have Ramona, who hers are sixths. The problem with doing it this way is, as you can see, I'm a terrible drawer, and this piece is way smaller than this piece. Plus, you should just be able to figure out that if you have, let's say, 1/4 and 1/6, you're going to get bigger pieces with the fourth, because you're thinking, oh, hey, I'm cutting this up and I'm only sharing it with 4 other people, instead of having to break it down to for 6 other people. Jorge rode his bicycle 2/5 of a mile. Andrew rode his 4/5 of a mile, and Julio rode his 3/5 of a mile. Who rode the farthest? So they're all parts of 5. So again, you could draw a picture and you could split this into 5 pieces, and you could say, okay, Jorge is this much, and you have Andrew is this much, and Julio is this much. So you can see that Andrew is the farthest, but the better way of doing this is to know that if they're all the same denominator, you know the largest numerator is the biggest one. So Andrew rode his the farthest. On the remembering side, we're back to these factor puzzles. So I'm going to do 4 with you, and I'm going to leave a couple for you to do yourself. Remember, you're asking yourself what number, and I'm going to go vertically first, what number will go into both 5 and 8? Well, 5 is a prime number, so the only number that will go into both 5 and 8 is 1. So now I can say, okay, what times 1 equals 8? And we know that that's 8, and I'm going to put that on both sides. And same thing, what times 5 equals 5, and that's 5. So I'm going to put that over there. Now I have my 8 here, and I'm going to say, what do I multiply 8 by to get 16? And that's going to be 2, and I'll bring my 2 up here. And the last one's the easiest because I just multiply those 2 together and get 10. Number 3 is a little bit trickier because the numbers are bigger. I'm going to go vertically again, and I'm going to say, okay, what's number will go into both 56 and 35? So I think, in my brain, I'm thinking, okay, I have 1 and 35, 2 doesn't, 3 doesn't, 4 doesn't, 5 and 7 and 6 doesn't. And then I'll look, does 35 go into 56? Nope. Does 7 go into 56? Oh, hey, yep. So 7 works. So I'm going to put 7 here. I'm going to put it on the top 2, and I'm going to ask, what do I multiply 7 by to get 56? And we know that that's 7 times 8. I'm going to move the 8 over here. What do I multiply 8 by to get 40? 8 times 5 is 40, and I'm going to bring the 5 down here. And then 7 times what equals 35? 7 times 5 equals 35, and I'll bring the 5 over here. Multiply those two together, and I get 25. So moving on to 6, I'm going to look here again, and I already listed my factors of 35, so I'm just going to look up here, and I'm going to say, oh hey, here's 7 again. 7 works for 21. 7 times what equals 21? Or 21 divided by 7 is 3. What times 7 gets to 35? 7 times 5 is 35. What do I multiply by 5 to get to 20? 5 times 4 is 20. And then 3 times 4 is 12. Last one, I'm going to go horizontally this time because it looks easier to me. All right, if I look at 16, I know that they're both even, but I know that normally we don't have double digits, so I know it's not going to be 2, but I'm going to try 4. And 4 times 4 is 16. 4 times 8 is 32. 8 times 3 is 24. Bring that 4 down, and then we're done. You're going to continue to see the area and perimeter of a triangle all year long. This is one that you really, really want to remember, and it will most likely be on the MCAs at the end of the year. Remember, for the area, you're taking the base times the height. It has to form the right angle, like it does here. You'll never take a diagonal for the area. So if I look here, I found my right angle. I have 7 times 8, but remember, it's taking half of one of them, so I'm going to half the 8 down to 4, and that gets me to 28. Now, if I didn't like halving it there, I could have left it at 7 times 8 is 56 and divided 56 by 2, and I still would have gotten 28. For the perimeter of this first one, these dashes, remember, mean that the sides are congruent, that all the sides are the same. So you have 8 plus 8 plus 8. Looks kind of like an angry face. Anyway, or I could say 8 times 3, or the perimeter is 24 inches. Here again, we have our little lines here that say they're congruent. So if this side is 10, this side is 10. So my area, I'm going to half one side and then multiply by 10. So I have 5 times 10 is 50 feet squared. Again, I could have left it as 10 times 10 and then divided that by 2, which would have been 100 divided by 2, which would have still gotten me 50. I just find it easier to half one of the sides when I can. The perimeter is 10 plus 10 is 20, plus 14 is 34 feet. Now for number 11, it is not a triangle, so I'm not halving anything. But because it's a parallelogram, I need to remember for the area that it's still the base and the height, not diagonal sides. The area has to be the right angle, 2 perpendicular lines. So I have 9 times 6 is 54 inches squared. But then my perimeter, here we go again, all the sides are, these have 1 dash, so they're both 7, and then these have 2 dashes, which means both of them are 9. So I'm going to think of it as 7 plus 9 equals 16, and I'm going to multiply that 16 times 2 because there's 2 other sides, and that gets me to 32 inches. At your lemonade stand, you charge 50 cents for a half cup and 75 cents for a full cup. At the end of the day, 12 cups have been used and you made $8. How many of each size drink did you sell? Now this is a little bit of guess and check. So I'm going to make a chart to keep my stuff organized. All right, so let's say I sold 2 half cups. And remember, they're 50 cents. So if I sold 2 half cups, that would mean, because I have to have 12 total cups, I need to sell 10 whole cups. And remember, I'm trying to get a total of $8 and 12 cups. All right, so I have my 12 cups. 50 cents times 2 is $1. 75 cents times 10 is $7.50. That gets me to $8.50. I'm actually way closer than I thought I was going to be. So I'm going to go back and I'm going to erase this. So that was a little bit too high, which means I need to lower my 75 cent. So I'm going to go up to $4 here. 4 cups, which means if I have to have a total of 12 cups, I need 8 75-cent ones. 50 cents 4 times is $2. And 75 cents 8 times 5 is 40. 56, 57, 58, 59, 60. I got super lucky. It only took me 2 guess and checks because 2 times 6 is 8 and 4 times 8 is 12. So the answer to your question is you sold 4 half cups and 8 full cups. And number 13 says, Anna is 3 years older than Laura. The product of their ages is double the sum of their ages. So again, we're going to do some guess and check. So here's Anna. Actually, I am going to switch, oopsie. And I'm going to do Laura first, and then I'm going to do Anna, because Anna is plus 3 from Laura. Okay, so let's just randomly throw out a number. If Laura is 2, Anna is 5. Okay, so now the product of their ages, which is multiplying, gets me 10. The sum of their ages gets me 7. Is 10 double 7? No, it is not. So, oops. I'm going to get rid of that, and I'm going to try again. So we have Laura and Anna. All right, so let's try if Laura is 5, that means Anna is 8. So if I add them together, I get 13. If I multiply them, I get 40. That isn't anywhere close. So I know that that did not work. Oops. So let's try this again. So we have Laura. We have Anna. Let's say that Laura... All right, so we know what numbers didn't work. Let's try if Laura is 3, Anna's 3 years older, so Anna is 6. Right? When we multiply them together, we get 18. When we add them together, we get 9. Is 18 twice of what 9 is? It is. So, Laura is 3 years old, and Anna is 6 years old.